Hello and welcome to Lesson 8-6 on solving systems of linear equations. In the last couple lessons, we learned how to graph linear equations using both tables and we used slope and y-intercept. Well, now we're going to solve systems, meaning more than one equation at a time. So objectives, you're going to be able to solve systems of linear equations by graphing, and you're also going to be able to use this whole idea to solve word problems. So we're going to go ahead and get started. First, what is a system of linear equations? Well, that's when you have two or more linear equations on one coordinate plane. Now, a solution of that system is any ordered pair that is a solution to both equations. So it can't just work for one of the equations. It has to work for both or all three if there's three. Otherwise, it's not a solution of that system. Now, how do you solve these? Well, you graph the equations on a coordinate plane and then see where do they intersect, because any point they have in common is considered to be a solution. So we're going to go ahead and get started right away with this. And here's what we have. Solve the system y is equal to x minus 7 and y equals 4x plus 2. In order to solve these, what you do is first just solve the first linear equation, and then secondly you do the second one. Alright, so how I'm going to do this is using that last method we talked about, using the y-intercept and the slope. So in this one, my y-intercept is negative 7. My slope is, well, just 1 over 1. So I go up 1 over 1. And I just keep on going, up 1 over 1. Now I'm going to make sure I try to cover the whole coordinate plane that way. And again, when I go the opposite of the y-intercept, I do the opposite, so down 1 over 1, and connect those dots. All right, and as I was saying before, you want to make sure you try to take up the whole table and try to get all the points in. That way, you can actually see where they intersect. So there we go. This one is y equals x minus 7. Next, we have this one, y equals 4 times x plus 2. Well, the y-intercept is 2. My slope is 4 over 1. So I go up 4 over 1. Up 4 over 1. Oh, I'm off the graph, so I'm going up now. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. All right, and then I go ahead and just connect those dots. And there we go. Now I look for my point of intersection, which is right here. This is where they share a common point, and that's going to be my answer. My coordinate here is negative 3. And on the y-axis, it looks like it's negative 10. And again, I can know this is a solution because I can put this into both equations and it should work. So for example, y equals x minus 7. If I put both in, negative 10 is the same as negative 3 minus 7. Well, negative 3 plus a negative 7 is negative 10. So that one checks out. And again, it should also be a solution to y equals 4 times x plus 2. So again, I can try it out to make sure it is. 4 times negative 3 is negative 12, plus 2 is negative 10. Both sides equal negative 10. So you can see this is a solution because both of them work out. Down here, which I'm just circling in blue, is all just work that I showed you. You don't actually have to do this piece in your assignment. So let's do another one. Solve the system y equals x minus 6 and y equals negative 2 times x. And go ahead and do this one with me as we do it. So first, I graph the first one. By negative 6, my slope is again 1 over 1. So I go ahead and just graph that one using rise over run. Up 1 over 1, up 1 over 1. Then doing the opposite on the other side of the y-intercept. And there I have my first one, y equals x minus 6. And I'm going to go ahead and graph this one now, y equals negative 2 times x. Well, my y-intercept, they're not adding or subtracting any number, so it must start at 0 or the origin. And my slope here is negative 2 over 1. Remember, whenever it's a whole number, it's always over 1. And starting right away, I already see the point of intersection, but I'm just going to go ahead and finish up at least a little bit of it. There we go. So connect those dots. And again, you have to excuse me, my smartboard's a little off. But there you go. This is y equals negative 2 times x. And the point of intersection is right there, which is let's see, on the y, or excuse me, x-axis, it's at 2. On the y, it is at -4. So my solution of that system is 2, -4. Final one, and I want you to solve this all on your own. And when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's go ahead and start this one. And I'm going to do this one very quick. That way you can just see what the solution is. There we go, that's my first equation. And again, you should be using a straight edge to connect those dots, so you should have a really curvy line like I do. All right, and then up. And there we go. That's where it connects, or it should connect right in there. So there we go. And my solution here is right there. That's where both points meet, and that is at -1, 2. So that should be your answer for that one. All right, so now we're going to talk about special systems. The 3 we've looked at so far, we've had 1 point. So 1 place where it actually worked out to be a specific coordinate. However, there are some special cases where you either have no solution or every solution or every coordinate basically would work on those. So I'm going to talk about a couple of these. If you have 2 equations where they are parallel, meaning there's no point of intersection, they don't cross, this system has no solution. And an example of that is right here. You can see they're parallel lines like a railroad, and they're not going to intersect. So you don't have an answer, so it's just no solution. That's what you'd write. Now, sometimes you get an equation where it's the same line. They just write it in 2 different ways. But if you have an equation where it's the exact same line, meaning the same slope, the same y-intercept, that means they share every single point in common. So for example, this example down here, well, this is a point, this is a point, this. I could cover this whole line in blue points. And I don't obviously want to write every single one down. That would be a lot of work. So when they talk about the same line, you write it's infinitely many solutions. So we're going to go ahead and practice this so you get a chance to see how they work. All right, so here's this one. Solve each system of equation by graphing. A, we have 27 times x plus 9 times y is 36. And then we have y is equal to 4 minus 3 times x. All right, well, looking at this, obviously the second one's going to be easier to graph first because it's already solved for y for us. So why don't we just do that one in green? My y-intercept here is 4, because that's the number they're adding and subtracting. My slope, the number of x, is this -3 over 1. So I go down 3 over 1. And again, I do the opposite, and then I can connect those points. There we go. So that's that one. Now, I have to do some work to solve that one, because as it is right now, I can't graph it. So, all right, there's a couple of ways you could do it. You could actually solve for y and do y equals like they did, or you could just start choosing some coordinates if you wanted to too. So, I think I'm going to solve for y. This is the whole idea of transforming formulas or changing them. All right, so first, of course, I have to subtract 27x, so that's on the opposite side. So now I have 9y is equal to, and I'm going to put -27x first. I like my coefficient, my term, before just my number here. There we go. And then to get y by itself, they're multiplying, so I divide. And thing to keep in mind, you divide every single term by that on both sides. So now I have -3x plus 4. So again, I could graph this one. Well, it starts at 4, and it goes down 3. Oh, oops, too far. Down 3 over 1, down 3 over 1, and it just keeps doing that. And you'll notice, well, when we do that, it's the same line. Because it's the same line, there are infinitely many solutions. So that would be my answer. Okay, and then let's do another one. Now on this one, we have 8 is equal to 4 times x plus 2 times y, and then we have 2x plus y equals 5. So on this one, we have to do work on both. So 8 equals 4x plus 2y to solve, and then let's go from there. And how do you solve them? Again, it's always about getting y by itself. So I have to get rid of that 4x. And now I have negative 4x plus 8 equals 2 times y. And of course, I divide by 2 to both sides, and each thing gets divided by 2. So sometimes I like to write it as 2 different fractions. That way I remember everything gets divided. So I have negative 2 times x plus 4 equals y. So I can start with that one, start at 4, down 2 over 1. And then of course do the opposite. And there we go, that's my first equation. And again, little shaky there. All right, and now I'm going to solve the other one. 2x plus y equals 5. Again, 2x is just on the same size as y, same side as y. So I just have to subtract it to get rid of it, because I want to move the entire 2x. So now I have negative 2x plus 5. Well, so here I start at 5, and I go down 2 over 1. Down 2 over 1. Down 2 over 1, and so on. And my shaky lines certainly did not help in this case, but if my line was a little straighter, you would notice that these actually don't share any points. They're just right next to each other. And like I said, I know it gets bad right there, where that is. So I'm going to try to fix that so that green line's a little straighter. Otherwise, it get a little bad. There. So taking a look at these two lines, all right, this system does not share any points in common. They're all different. So this time, there's no solution. All right. So when you do these graphs, there's 3 different things that can happen. First, you could have a point of intersection, and that would be your answer. You could have, like that last one, they share the same line, and there's infinitely many. Or if they share no points in common, there's no solution. All right, so now we have a word problem of it that we're going to try. And these can be a little funny, but we're going to go ahead and try one. Well, they can be fun. So here we go. Find 2 numbers with the sum of 10 and a difference of 2. Now, step 1, you have to first write the equations. And we're going to use those variables x and y, because that's what we see normally when we talk about equations. So we know we have 2 different equations. One where they talk about a sum of 10, and another one where they talk about a difference of 2. So if we let x be the greater number and y equal a smaller number, and we're talking about the sum, well, our first one is going to be x plus y equals 10. Because the sum of those 2 numbers that we don't know, that's why we use x and y, equals 10. But then it says the difference between them is 2. So here we have x minus y equals 2. Now, again, you can solve for y. I'm going to show you one way to do one, and then I'm going to show you another way to do the other. All right, one way you could do this, if you really wanted to, is use a table. We've done tables before. So to make this true, if x was 0, y is 10. If x was 1, y is 9. So just pick numbers that would work in this equation. If I put 5 in, well, then it would be 5. If I did 6, this would be 4, and so on. And it just continue. So all of these could be answers to it. So I could graph these. 0, 10, 1, 9, let's see, 2, 8, 3, 7, 4, 6, 5, 5, 6, 4, 7, 3, 8, 2, 9, 1, and 10. So that is what that equation would look like. So that's one way you can do it. And again, you could do it for this one as well if you wanted to. Or another way to do it, solve for y and then do the slope and y-intercept. So maybe that's what I do here. My whole job is to get y by itself. So this time I'm going to subtract y from y is positive right away. And I have 2 plus y. Well, I'll subtract 2 to both sides. And I'm left with x minus 2 equals y. So I can graph this. Well, I know I start at negative 2. My slope is 1 over 1. So I go ahead and do that. And then we look for that point of intersection where those 2 lines meet. That'd be my answer. So, and it looks like they meet right here at 6, 4. So, and you could take a look and make sure that's true. The larger number, 6 plus 4, is equal to 10, and 6 minus 4 is 2. So 6, 4, that coordinate actually fits. It's a solution. So that was our lesson for tonight. We talked about how to solve systems of linear equations. You have a great night, and I will see you all in class tomorrow. Good night.